Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a fascinating new paper titled O3N, which focuses on omnidirectional open vocabulary occupancy prediction. That sounds like a mouthful, but it basically describes an AI that can see in every direction and understand exactly what it is looking at. Currently, most robots and self-driving cars use cameras that only see a small slice of the world at one time. This creates blind spots and makes it difficult for them to navigate safely in complex environments. Furthermore, these machines are usually limited to a fixed vocabulary, meaning they can only recognize things like car or person because that is all they were taught. The researchers point out that if a robot encounters something new, like a specific type of box or a stray dog it hasn't been trained on, it might get confused. To solve this, the authors created O3N, the first purely visual system that sees in a full 360-degree circle and understands open-ended language. This means instead of a rigid list of labels, the AI can use text descriptions to identify almost anything in its path. One of the biggest hurdles with 360-degree images is that they are often distorted, much like how a flat map of the Earth looks stretched at the poles. As seen in these diagrams, objects that are far away or at certain angles can look very different to a computer than they do in real life. The researchers developed a clever way to project these flat images into 3D space so the machine can accurately judge distances. The O3N architecture, shown here, uses a multi-step process to turn a single panoramic image into a detailed 3D map. It uses a special module called the Polar Spiral Mamba to help the AI process the 360-degree view without getting tripped up by distortions. This allows the system to maintain a continuous understanding of the space around it, rather than seeing it as a series of disconnected snapshots. Another key innovation is the way the system aligns pixels, voxels, and text. A voxel is essentially a 3D pixel, and by linking these to text descriptions, the AI can read the world around it. This allows it to understand that a certain cluster of 3D space represents a bicycle or road based on language clues. The team also introduced something called natural modality alignment to bridge the gap between images and words. This helps the AI stay consistent, ensuring that what it sees visually matches the meaning of the words it is using for identification. By doing this, the researchers have made the AI much better at identifying novel objects it didn't study during its initial training. To test their work, the authors used datasets from real-world robots and simulated environments. As shown in the performance tables, O3N significantly outperformed existing methods, especially when it came to recognizing new categories of objects. It even managed to beat some systems that had the advantage of cheating by using more data or simpler perspectives. In these visual results, you can see how the O3N system creates a much clearer and more accurate 3D representation than previous methods. While older versions might see a vague blob, this new system can clearly distinguish the shape of the ground, buildings, and vehicles. This clarity is essential for a robot to move through a room or for a car to drive down a busy street without hitting anything. So, what does all of this mean for the future? By allowing machines to see in 360 degrees and understand the world through language, we are moving closer to truly intelligent agents. This technology could make autonomous driving much safer by eliminating blind spots and improving object recognition. It also means that the robots of the future will be much more adaptable to new places and situations. The researchers believe this is a key step toward universal 3D world modeling for all kinds of embodied intelligence. Thank you for watching Summarize Science, and stay tuned for more deep dives into the future of tech.